at two different goals with matrices today. The first example is being able to first set up a matrix and analyze what's in a matrix. And then the remaining examples are working with different algebraic operations on matrices. So specifically, we're looking at adding, subtracting, and multiplying matrices by a constant. And then we'll actually look at multiplying two matrices together tomorrow. That's a little bit more of a process. So what I have included at the top, because I know matrices are new to a lot of you, most of you. So what a matrix is, it is a rectangular array of variables or constants in rows and columns. It's a way to organize data, is what a matrix is. These are usually enclosed in brackets, so you can see this is an example of what a matrix looks like. In a matrix, the numbers or data are organized so that each position in the matrix has a purpose. And then each value in a matrix is called an element of the matrix. And these are usually named using an uppercase letter. So in this matrix here, you can see the matrix is called matrix A, and it's capital A. And matrices, as we're going to look down here, they can be described by their dimensions. So the size of the matrix, the dimensions of a matrix are important. So looking at this matrix, and this might honestly seem like common sense to some of you, but it very easily gets switched around. So you're looking at the number of rows in a matrix and the number of columns in a matrix. The rows are the horizontals in a matrix. So in this matrix A, there's 3 rows. Those are the horizontal arrangements there. And then the columns are the vertical arrangements. So there's 4 columns in this matrix A. And it does also, like I said, I know it's very hard to see up here, and it's very light on your sheet. The other 2 small boxes, along with that, though, they're pointing to specific numbers or elements in the matrix. And this is just showing that if a matrix, for example, appears in row 2, column 1, like this -1 here, the placement of an element matters. So where each number is in a matrix does matter. They do describe one way it's named. This says A with a subscript 2, 1, the 2 for being row 2, the 1 for being column 1. This, though, I'm never going to ask you to kind of label this type of information for me. So that's just information about how the different elements can be depicted, but for our purposes, you don't really need to understand that notation. We don't use it. I do need you to be able, though, if I asked you what element is in row 2, column 1, that you could tell me that. But actually writing it this way, you don't have to worry about. But because this matrix has 3 rows and 4 columns, this is how the dimensions of a matrix are defined. So a matrix with m number of rows and n number of columns is an m, and this is read m by n, so not m times n, but m by n matrix. So because there's 3 rows, 4 columns, matrix A would be called a 3 by 4 matrix. The dimensions of a matrix do matter, especially when you're working with performing algebraic operations on a matrix. There's certain matrices you can't add together. There's certain matrices you can't multiply together because of their dimensions. All right, so we're going to get into example 1, which again, example 1 is just setting up and analyzing a matrix. So it says data that are organized in a matrix can be analyzed and interpreted. We're going to see with these questions that sometimes further analysis would be needed, but other times the data are meaningless, meaning it doesn't make sense to perform a specific operation with the numbers in a matrix. We'll kind of see that with the questions we go through. So example 1 is giving us information about 3 universities in Iowa. So it says Caitlin wants to attend one of 3 Iowa universities next year. She's gathered information about each school's tuition, which is the capital T, room and board, which is the R/B, and enrollment, which is E for the universities. So in part A, it says organize the data as a matrix with the columns in the order of tuition, room and board, and enrollment. So we're going to set up a matrix. I'm going to have 3 columns. Column 1 is going to be all of the tuitions. Column 2, all of the room and boards. And column 3, all of the enrollments. So I'll be listing those there. How would the data in the rows be organized then? What would each row represent?
The school.
Each school, yes. So Iowa State University, I'm just going to abbreviate this ISU, and I'll put Iowa State University's information in the first row, University of Iowa, UI, for the second row, and then University of Northern Iowa in the third. All right, so if I just start filling this in, I'll fill in all of Iowa State University's information first. So their tuition, I'm getting this information from above. Their tuition is $6,160. Room and board is $5,958. And enrollment is $26,160. And then for the University of Iowa, the tuition is $6,293. Room and board is $7,250. Enrollment is $30,409. And University of Northern Iowa, tuition is $5,352. Room and board is $6,280. And enrollment is $12,609. And then I'll just fill in my brackets around that to form my matrix. And notice the actual labels of the schools are on the outside. So the matrix is just those 9 numbers that are in there. It doesn't ask for this, but what are the dimensions of this matrix? 3 by 3, yes. So there's 3 rows for the 3 schools, and then 3 columns for the tuition, room and board, and enrollment. All right, so that's, if you're asked to organize the data as a matrix, that's how you do it. They might specify what they want the columns to be or the rows or maybe both. And then in part B, it says find the average of the elements in column 1 and interpret the results. So in column 1, we have those 3 values. How do you find the average? Add them all, divide by 3, because there's 3 of them. So 6160 plus 6293 plus 5352. That's sum divided by 3. And when someone has it, just want to share what that is. Is that just the sum? And then, yeah, divide that by 3. Not a problem. 5,935. All right, so that's the average. It then does say interpret the result. So what does that 5,935 represent? The average tuition of the 3 schools. So the average tuition is $5,935. So that's an instance where averaging the first column, we get a value that is meaningful. And meaningful doesn't mean is it meaningful to you personally. You take your opinion out of it. Meaningful just means does the number actually represent something? Does it make sense to average those values? In this case, it would give us the average tuition. So then in part C, this is asking, would adding the elements of the rows provide meaningful data? So rows are the horizontal. So would it make sense, is what this is asking. For example, in the first row, would it make sense to add those three numbers together? I saw some yeses and I saw some no's. Are there any reasons either way why it's yes or no? It would make sense or it would not make sense? Okay, and I'm glad you said that. Total cost. Do all three of these numbers represent a cost? One of them is enrollment. Enrollment is not money, but it's what? How many people? So in each row, tuition is a dollar amount, room and board is a dollar amount, but enrollment, this is a number of people. So if I added all three of these together, I'm adding $2 amounts with a number of people. That doesn't really make sense. So does this make sense, or is it meaningful? No, because there's different ways you could describe this, but we could say the three columns are different measurements, or are not all the same measurements. Two of them are measuring dollar amounts, one of them is measuring people. So we could have said that more specific as well. Columns 1 and 2 are dollar amounts, column 3 is a number of people. So that's where you have to see, looking at that matrix, what operations would make sense in the matrix and what wouldn't make sense. But I'm glad if some of you were thinking, well, yeah, they're all dollar amounts, I'm glad you were thinking that, because you really have to pay attention to what those units are, what's in the matrix. And then part D, would adding the elements of the third column provide meaningful data? So now if you look at a column is vertical, the third column, would it make sense to add those three numbers together? They're different colleges, but are they all the same units? They're all people, right? If I added them together, what would that total give me? It wouldn't give me the average, but the total enrollment for all three. So again, meaningful doesn't mean meaningful to you, but maybe in Iowa, they're saying, okay, in these three universities, how many people enroll? That's what that value would give me. So it is different schools, but it's all people we're adding together. So we could say yes here, and say the sum, so adding the three, the sum would represent the total enrollment of the three schools. So a way to work through answering those questions, is it meaningful, is say, okay, if I did what they're asking me to do, if I added the three numbers in this column, what would that number represent? And if you can't come up with what it would represent because you're adding different quantities together, then it's probably not meaningful. Allie? Like, are you asking would it be meaningful to her to know that? Yeah, right, and that's why I'm trying. I worded it the way that it would be worded in the question. But when you see meaningful, think to yourself, would it make sense to add all three? Would I get a number that represents something that would make sense? So would the total enrollment be meaningful to her? Probably not. But it does represent total enrollment, so it's not that it wouldn't make sense to add them. Yeah. All right, are there any other questions right now on setting up a matrix or analyzing it? And again, if it says meaningful, kind of take your opinion out of it and just think about the units. Does it make sense to add them or average them, whatever it's asking. All right, then we can move on to the operations with matrices. And like I said, today we're focusing just on adding, subtracting, as well as multiplying by a constant. So it does say at the top, I'm going to look at the second sentence here, matrices can be added or subtracted if and only if, that should say they, not the. They, this other one, sorry. Wrong the. If and only if they have the same dimensions. So this is, again, where knowing the size of a matrix does matter. If two matrices have different dimensions, you cannot add or subtract them. So in this box, this is just for your reference, but it shows you how to add or subtract matrices if they have the same dimensions. So just looking at this first row where we're adding matrix A and matrix B, what dimensions do both of these have? How many rows, how many columns? 2 by 2. And then what I want you to notice is the sum, adding A plus B, is also going to be a 2 by 2. So your dimensions will stay the same. Ultimately, to add or subtract, you just add or subtract the corresponding elements together. So in row 1, column 1 of A, that would be added to row 1, column 1 of B, and that goes in row 1, column 1 of your answer. And you would actually add A plus E, whatever that is, that value would go there. Same with subtracting, you're just subtracting instead of adding. And then it does give a specific example. They're just showing you here what's being added together. So just know you wouldn't leave it like this, like you would have 3 plus 2 is 5. You'd have 5 there. So we're going to go through some examples. So in example 2, it says for these matrices A, B, C, wants us to find the following, or if we can't find it, to state that we can't find it. So part A, we're adding A plus B. So I want to look at these 3 matrices first and just list the dimensions. What are the dimensions of matrix A? So A has 2 rows. How many columns? 2. What about matrix B? 2 by 2. What about matrix C? So here again, you have to think, what's a row, what's a column? How many rows? There are 2 rows. How many columns? 1. So it's 2 by 1. All right. So can we add A plus B? Yes, they have the same dimensions. So to add these, my matrix is still going to end up being 2 by 2, so I add the corresponding elements. So I would add 16 plus negative 4, so that would be 12. And then row 1, column 2, so then 2 plus negative 1 is 1. And then negative 9 plus negative 3 is negative 12. And 8 plus negative 7 is 1. So that 2 by 2 matrix is my sum A plus B. Questions on that? All right, part B, matrix B minus matrix C. First of all, can we subtract those 2 matrices? No, they have different dimensions, so this is not possible. Or you could write impossible as well. They do not have the same dimensions, so you cannot subtract them. And that hopefully makes sense if you're supposed to add or subtract the corresponding elements. If they're not the same size, you're unable to do that. And then part C, matrix B minus matrix A, are we able to subtract those two? Yes. So if I do that, subtract the corresponding elements, so I need to do B minus A. So I would have negative 4 minus 16, so that would be negative 20. And then negative 1 minus 2, that's negative 3. And negative 3 minus negative 9 is really negative 3 plus 9, so that's 6. So careful with subtraction, especially if you're subtracting a negative. And then negative 7 minus 8 is negative 15. So that would be your difference, B minus A. So ultimately, you're adding and subtracting. I get that. It's really not difficult to add or subtract, but you have to know how to do that in a matrix, and you still need to pay attention to what you're doing and not make a careless mistake. All right. Moving on then to multiplying by a constant, and for matrices, so you have to know the terminology, the vocabulary as well. When you multiply a matrix by a constant, it's called a scalar for matrices. So you're multiplying by a scalar, so that's called scalar multiplication. And when you do this, you multiply each element in the matrix by the value of that scalar. So it shows in this box here, if we have a scalar k and then matrix A, so we're multiplying matrix A by that scalar, and it shows that down here as well. Notice when I multiply that matrix by the scalar, I'm just multiplying every element by k. And it shows that below with a more specific or concrete example, multiplying everything by negative 3. So in example 3, if I have matrix R, it wants me to find 5 times R. I know this does not really matter in this situation, and it's not asking for it, but just to practice it, what dimensions does matrix R have? Three by 2 or 2 by 3, which one? How many, so rows come first. How many rows? 2. So it's 2 by 3 columns. So it is easy to get that mixed up, but it makes a huge difference. 2 by 3 and 3 by 2 are not the same. So that's why I'm asking you that now. So 5 times R would be if I multiplied every element in my matrix. So all 6 of these numbers, I multiply them by 5. So the placement of the numbers stays the same, but I'm multiplying them all by 5. So I would have negative 12 times 5, so negative 60. And I'm going to go across the row. 8 times 5 is 40. I'm writing that I'm finding 5 times R, and it's going to equal this matrix. Is that what you meant, is including the R here? Oh, like here you mean? Yeah. Yeah, so I could have written 5 times R. I could have written this way as 5 times, and then matrix R would be this. And then, yep, and then I'm multiplying it right away. Yeah. And then 6 times 5 would be 30. And then in row 2, negative 16 times 5 is negative 80. 4 times 5 is 20. 19 times 5 is 95. So this matrix here would be our answer. Questions on that? All right, so then what example 4 is asking you to do, it says above it that multi-step operations can be performed on matrices similar to evaluating expressions. These are evaluating expressions that involve matrices. Order of operations is the same as with real numbers. So when you're working with matrices, you are still following order of operations. So example 4 gives you matrix A, matrix B, and it wants you to find -6 times matrix B plus 7 times matrix A. So your answer is 1 matrix. So I want you to work on this in your groups, come up with what that matrix would be as a final answer. If you have questions as I walk around, let me know. Allison's going to show, she has example 4 so you can check what you have with hers and make sure that you have it correct.
Okay, so what I did was for all the A's, I plugged it in for the A and then did the B for the B. And then here's all of the A's and there's all the B's and then I added them or stretched them together to get the final.
So she has, the first one was the 7 times the A, the second, the -30, and everything that was the -6 times B, and then she has the final. And this was a question that was asked when I walked around is, like Allison showed that she multiplied A times 7, and she showed what those values were, and then -6 times B, and she showed what those values were. Do you have to show that? My answer to that was no, but if you just have an answer on a quiz and it's wrong, and I don't know where your mistake was, you're not going to get partial credit. Versus, say Allison got one value wrong, so her answer is wrong, well, that might be minus a half because I can see exactly what value she got wrong. It was one little mistake. Otherwise, I have no idea how you got your answer if you're not showing how you did it. So that's, I know I always ask you to show your work, but really in a quiz, that's why. I can't see how you did it, you're not going to get partial credit. I don't know where your mistake is. And then you don't know where your mistake is either if you don't write it down. Are there any questions on example 4? Okay.